Okay, so happy Friday. Today we're going to cover one physics topic. It actually, there's a mistake up here. It should just be density is all we're doing. We're not going to do center of mass. This is something that Caitlin and I decided to remove from responsibility this semester after I had already printed this calendar. So just density. Next class we talk about work. The following class economics, and then a week from today probability, followed by our review day and then our test number 2. Coming up Monday will be project number 5. That's the chocolate one is due, and I will hand you project 6. Any questions on the calendar? Project 6 is due April 6th, whatever that is, Monday. Yeah, the following Monday. Okay, so top of page 49, we'll start with our daily summary. Cameron. Thank you. Gabe. Okay, let's jump down to 2 and then we'll come back to the formulas. Steve, number 2. Okay, so take 30 seconds, talk to your neighbors, no fancy formulas, just see if you can answer that question. Okay, it is very dense. All right, so what do we do here with the 3? The cubit, and that gives us the volume, right? So the volume is 27 cubic inches, and then what are we doing to find the mass? Multiplying it by that density, right? So then our answer here is just this 54, whatever it is, pounds. Okay, so that's the mass of this pretty small cube, and I think we just use this formula right here without knowing or without looking at it, right? Just the mass is the volume times the density. But if it were a 2-dimensional object, then it would just be area times density. 1-dimensional thing would be just the length of it or the distance times density. One small detail, I don't get hung up on this, but technically 54 pounds is not a mass. Why not? It's a force, right? It's a weight, which is slightly, which incorporates the effects of gravity, right? So, but I'm not going to worry about like, I abuse the word mass. I should, should have called it the weight. It's really weird, and it's like foot-pound slugs or something silly. Like in anybody know what it is in the English system? I mean, it should be just kilograms. Like we shouldn't have any other mass word besides kilogram, but we do. Grams are a mass and pounds are not. Yeah. Okay, let's go to 3. Cooper. So suppose that cube right there, which had a uniform density in the previous problem, no longer has a uniform density, but rather it's more dense to the left of the cube and less dense to the right of the cube. So maybe we have to slice this guy, and so that we're looking at little slivers of things that roughly have a constant density, and then we'll add up all these little masses, right? And then an integral. Okay, so let's try number 4, Petru. Thank you. Why is it impossible? Okay, so we've got this muddy water taking up the bottom 10 feet of this 21-foot tall barrel. It's a big barrel. What's that? Yeah, the 21 feet, we just need to do 0 to 10 is what we're interested in here. And And then it says that the density of the water varies linearly, and it says at the bottom it's the heaviest stuff. Does that make sense, that the heaviest stuff would sink to the bottom? So 40 pounds per cubic foot is what's going on at the bottom. And at the top is where it's mostly water and not too much mud, is only 30 pounds per cubic foot. And we're just going to assume a linear relationship that will get you from 30 to 80 over those 10 feet, okay? That's the varying linearly. All right, so what we're interested in is finding the mass of all of this stuff. Unfortunately, you can't just do the volume of the water times a number because there is no constant density in this barrel, right? It changes. But what we're going to do is slice the water here in such a way that the slabs of water that we create have essentially the same density as each other, just a constant density. There's two kind of natural ways to slice. I mean, I suppose you could slice at like different angles and things, but the typical ways to slice are vertical and horizontal. In which one of those slices does all the water have approximately the same density as horizontal, right? If you slice vertically, the stuff at the top is very different than the stuff at the bottom, but if you slice horizontally, as long as it's not very thick, then the stuff at the top of your slice isn't that different from the stuff at the bottom of your slice. Susanna. If you slice vertically, then... Oh, yeah, I suppose that each slice would have the same density or average density or something, but I think it would be hard to get our hands on what that number is. Yeah. Then you could go backwards. Yep. You can, and that's way easier than what we're going to do. So instead of doing that, right, I mean, because we could just find the average of 10 and 80, and the average density in this barrel then is whatever that number is, 55 pounds per cubic foot. Like this is now an easy cube problem because we've made this nice leap that says, oh, the average molecule in here has a density of 55, so we'll just treat them all like a density of 55. But that's only because it's linear. And if it were anything other than linear, then we wouldn't be able to just use this nice trick to get the answer, right? But Cooper provided the trick. So how about we just jump to the answer here, and then we'll confirm it using our calculus idea. So Cooper's trick, which is not recommended that you employ on a test. Let's see. So the average density we said is 55, right? 55 pounds per cubic foot. How would we find the volume? Pi times, what's the formula for the volume of a cylinder? Pi r squared times the height. Okay, so what's the radius of this guy? 3.5, so 3.5 squared times the height, 10. Okay, so that's our answer. Somebody can type that into a calculator for us, and we'll get that in a second. 21,166. Give me a few digits. Okay, so we know that this is the answer. It's that many pounds is the mass, although again, it's not a mass, that's a weight. Okay, so the whole barrel is 21,000 pounds and change. All right, so let's do this the calculus way. So we're going to take this muddy water, we're going to slice it up horizontally, make these cross sections. And so I'm going to draw one cross section there, and then another one right above it. This is a much thicker slab of water than I'm really envisioning. I'm just trying to make it so we can see the darn thing. Right, we're going to make this guy, it's also kind of slanty. So it's a curvature of the earth thing, that's why. So there's our slab of water, and we're going to do the same idea that we did before. So we're going to find the mass of the slab is equal to the density for whatever is going on in that slab, and then multiplied by what geometric word? The volume. It's the same density times volume we did up above, just focused on a little thin slab of water. Okay, let's try the volume part first. I think that's going to be easier. We know the volume of that slab. Well, what shape is that red slab? That is well, there's two circles and everything in between. It's a cylinder, yes? And I suppose you could call it yeah. A cylinder and disk, are they different? Is disk a two-dimensional word? So it's a disk with some thickness. Yeah, so cylinder, right? It's a really thin cylinder. And we know the formula for the volume of a cylinder is pi times the radius squared times the height. So pi times the radius is still 3.5, that's easy, and then squared, and then times the height. So how about we give a name to the height? Delta H. Delta X is fine, but for me it's a little change in height. So times delta H. That's a multiplication symbol. So what I'm after here is the density, but the density is no longer a number, right? It changes depending on where that red slab of water is. And so we need a formula here. So how about we say that H is the distance between the bottom of the barrel and the slab. So let's invent what we're calling H, totally our choice here, but let's say that from here to here, this distance right here is what we're going to call H. Yes, I'm just trying to use the same letter. I know that when we go to the integral, it's going to be some letter and then d that same letter. So delta H is a constant, H is the varying thing going up and down, but I am trying to make them match. Yep. Okay, so we just need a formula, right? And the formula is supposed to get us from when H is 0, the density is 80, up to when H is 10, the density is 30. So if you want, yeah, I mean, so you might be able to just come up with the equation that relates the density to the height, but if you can't, then you can just make a few ordered pairs. We know this Greek letter? Not lambda, not gamma. It's delta. It's a lowercase delta. You guys know the capital delta looks like a triangle. That's a lowercase delta. Delta is the letter we use for density. So if the height is 0, that means that we're at the bottom, and the density is supposed to be 80. And if the height is 10, then the density is 30. And so now it's like, go back to some algebra class from your past and find the equation of the line that hits those 2 points. So we definitely have to find the slope, yes. What is the slope? Yeah, let's see, it's a 50 over -10, so -5. And so that means that I think we're ready to write our equation. I'm thinking mx plus b, but I'm writing delta and h. M is this -5 that we just found. The y-intercept was a gift in this case, right? It's just 80 because of the 0. Almost. Any questions on coming up with that linear equation? And then we can make sure that it works, right? I mean, like if you plug in 10 for h, what do we get? We get the 30 that we expected, and then we just get linear stuff in between. Okay, so then that formula right there is the density of that red slab, and it changes depending on where the red slab is. But that density is exactly what we were after up here. So I'm going to put that right in here. -5h plus 80. Right? It's not a constant. Depends on the height. Depends on where your slab is. But for all the water molecules in that particular slab, the density is pretty much constant. We're assuming the slab was fairly thin. Yeah, we need the same variable. So that would be the mass of the one slab. But we've got lots and lots of slabs, maybe hundreds or thousands of these slabs. And so to find the mass of all the water, what are we going to do with the masses of all these slabs? We're going to add them all up in a sum, sigma. And then if we make more and more slabs, that sigma becomes an integral. And so let's go to our integral. So this is now the, I'll say mass of the whole thing, mass of all integral. Got my formula, just copying it. Negative 5h plus 80 times pi times 3.5 squared. Delta H becomes dH. Great. Yeah, and then just imagine that red slab sliding up and down. H is how much at the bottom? 0, and at the top, 10. Okay, so that's the end of the demo. I know typically we say don't worry about doing the antiderivative or integral, we'll just use the calculator, but the beginning of the activity, I would love for you to do this by hand, or at least don't use the integration function on your calculator. So can you guys do that by hand and then move on to the demo or the activity? Starts on the next page. And we better make sure we get Cooper's answer, right? 21,166.